Hi, everybody. Let's see you again, and let's start our lecture on astronomy course. Okay. So today, our class, the topic of our class is Introduction to Astronomy. And remember about my last question in previous lecture. Immediately, if you need to clarify something, you're using our chat or my email you may see on this. Okay, so let's go. But generally, try to understand in a whole from our video. Let's continue our class. Once you have an idea where you are in space, you need to know where you are in time. The stars have shown for billions of years before the first human looked up and wondered what they were. To get a sense of your place in time, all you need is a long red ribbon. Imagine stretching a ribbon from a goal line to goal line down the center of a football field, as shown, uh, as you may found in many sports games and such. Imagine that one end of the ribbon is today, and that the other end represents the beginning of the universe. The moment of beginning that astronomers call the Big Bang. In the lecture Modern Cosmology, you will learn all about the Big Bang, and you will see evidence that the universe is about 14 billion years old. Your long red ribbon represents 14 billion years, the entire history of the universe. Imagine beginning at the goal line labeled Big Bang. You could replace the entire history of the universe by walking along your ribbon towards the goal line labeled today. Observations tell astronomers that the Big Bang filled the entire universe with hot, dense gas. But as the gas cooled, the universe went dark. All that happened in the first half inch on the ribbon. There was no light for the first 400 million years, until gravity was able to pull some of the gas together to form the first star. That seems like a lot of years, but if you stick a little flag beside the ribbon to mark the birth of the first star, it would be not quite 3 yards from the goal line where the universe began. You would go only about 5 yards before galaxies form in large numbers. Our home galaxy would be one of those taking shape. By the time you cross the 50-yard line, the universe would be full of galaxies, but the sun and earth would not have formed yet. You would have to work past the 50-yard line down to the 35-yard line before you could finally stick a flag to mark the formation of the sun and planets, our solar system. You would have to carry your flag a few yards farther to the 29th-yard line to mark the appearance of the first life on Earth, microscopic creatures in the oceans only. You would have to walk all the way to the 3-yard line before you could mark the emergence of life on land. And your dinosaurs lab would go just inside the 2-yard line. Dinosaurs would go extinct as you passed the 1/2-yard line. Did you get it? What about people? You could put a little flag for the first human-like creatures only about an inch from the goal line labeled today. Civilization, the buildings of cities, began about 10,000 years ago. You have to try to fit that flag in only 0.00026 inches from the goal line. And that's half the thickness of a sheet of paper. Compare the history of human civilization with the history of the universe. Every war you have ever had, or every person whose name is recorded, every structure, every built from Stonehenge, as you see in this slide, to the building you are in right now, fits into that 0.0026 inches. Humanity is very new to the universe. Our civilization on Earth has existed for only a flicker of an eye blink in the history of the universe. As we will discover in our next classes, only in the last 100 years or so have astronomers begun to understand where they are in space and in time. Your exploration of the universe will help you answer two fundamental questions. What are these? How do we know? Let's start from the first question. What are these? That is the first organizing team of our class. Astronomy is important to you because it will tell you what you are. Note that the question is not who are we. If you want to know who we are, you may want to talk to a sociologist, theologian, paleontologist, artist, or even a poet. What are these is a fundamentally different question. As you study astronomy, you will learn how you fit into the history of the universe. You will learn that the atoms in your body had their first birthday in the Big Bang when the universe began. Those atoms have been cooked and remade inside stars, and now, after billions of years, they are inside you. Where will they be in another billion years? This is a story everyone should know. And astronomy is the only course on campus that can tell you the story. Every class in our course ends with a short segment titled, What Are You? And this summary shows how the astronomy is related to your role in the story of the universe. How do we know? That is the second organizing theme of our course. It is a question you should ask yourself whenever you encounter statements made so-called experts in anything. Should you swallow a diet supplement recommended on a TV star? Should you vote for a candidate who warns of a climate crisis? To understand the world around you and make wise decisions of yourself, like unannounced war aggressive from Russia into Ukraine. For your family and for your nation, you need to understand how science works. You can use astronomy as a case study in science. In every class of our astronomy course, you will find short essays titled How Do We Know? They're designed to help you think not about what is known, but about how it is known. That is, they will explain different aspects of scientific reasoning and in what they help you understand how scientists know about the nature of world. How do scientists learn about nature? You have probably heard of the scientific method as the process by which scientists form hypotheses and test them against evidence gathered by experiment or observation. Scientists use the scientific method all the time, and it is critically important, but they rarely think of it. It is such an ingrained way of thinking about nature that it is not almost invisible. Scientists try to form hypotheses that explain how nature works. If a hypothesis is contradicted by experiments or observations, it must be revised or discarded. If a hypothesis is confirmed, it must be tested further. In that very general way, the scientific method is a way of testing and refining ideas to better describe how nature works. For example, Gregor Mendel was an Austrian abbot who linked plants. He formed a hypothesis that offspring and usually inherited trait from parents, not as a smooth blend, as most scientific of the time believed, but according to strict mathematical rules. Mendel cultivated and tested over 28,000 pea plants, noting which produced smooth spears and which wrinkled spears and how the tree was inherited by successive generations. His study of pear plant and other confirmed his hypotheses and allowed the development of a series of laws of inheritance. Also, the importance of his work was not recognized in his lifetime. It was combined with the discovery of chromosomes in 19 and 15. And Mendel is now called the father of modern genetics. The scientific method is not a simple mechanical way of grinding facts into understanding. It is, in fact, a combination of many ways of analyzing information, finding relationships, and creating new ideas. A scientist needs insight and ingenuity to form and test a good hypothesis. Scientists use the scientific method almost automatically, forming, testing, revising, and discarding hypotheses almost minutes by minutes as they discuss a new idea. Sometimes, however, a scientist will spend years studying a single important hypothesis. The so-called scientific method is a way of thinking and a way of knowing about nature. The How Do We Know essay is a chapter that follow will introduce you to some of their methods. You sort the universe by taking a cosmic zoom in which each field of view was 100 times wider than the previous field of view. Astronomers use the metric system because it simplifies calculations and use scientific notation for very large or very small numbers. You live on a planet Earth, which orbits our star, the Sun, once a year. I hope you know that, right? As Earth rotates once a day, you see the sun rise and set. The moon is only 1/4 the diameter of Earth, but the sun is 109 times larger in diameter than Earth, a typical size for a star. The solar system includes the sun at the center and all of the planets that orbit around it: Mercury, Venus, Mars, Jupiter, Saturn, Uranus, and Neptune. The astronomical unit AU is the average distance from the Earth to the Sun. Mars, for example, orbits 1.5 astronomical units from the Sun. The light year is the distance light can travel in 1 year. The nearest star is 4.2 light years from the Sun. Many stars seem to have planets, but such small, distant worlds are difficult to detect. Only a few hundred have been found so far, but planets seem to be common, so you can probably trust that there are lots of planets in the universe, including some like Earth. The Milky Way, the hazy band of light that encircles the sky, is the Milky Way galaxy seen from the inside. The Sun is just one out of the billions of stars that fill the Milky Way galaxy. Galaxies contain many billions of stars. Our galaxy is about 80,000 light years in diameter, and it means this one, and contains over 100 billion stars. Some galaxies, including our own, have graceful spiral arms brimmed with stars, but some galaxies are plain clouds of stars. Our galaxy is just one of billions of galaxies that fill the universe in great clusters, clouds, filaments, and whorls, the largest thing in the universe. The universe began about 14 billion years ago in an event called the Big Bang, which filled the universe with hot gas. The hot gas cooled, the first galaxies began to form, and stars began to shine only about 400 million years after the Big Bang. The sun and planets of our solar system formed about 4.6 billion years ago. Life began in Earth's ocean soon after Earth formed, but did not emerge onto land until only 400 million years ago. Dinosaurs evolved not long ago and went extinct only 65 million years ago. Human-like creatures appeared on Earth only about 4 million years ago, and human civilization developed only about 10,000 years ago. Also, astronomy seems to be about stars and planets. It describes the universe in which you live, so it is really about you. Astronomy helps you answer the question, what are they? As you study astronomy, you should ask, how do we know? And that will help you understand how science gives us a way to understand nature. The night sky works as a scene from our planet. When you look up at the stars, you are in the rest of the universe looking out through a layer of air, only a little more than 100 kilometers deep. Beyond that, space is nearly empty, and the stars are spread light years apart. As you uh, study these classes, keep in mind that you live on a planet in the mindset of these scattered stars. Because our planet rotates on its axis once a day, the sky appears to revolve around you in a daily cycle. Not only does the sun rise in the east and set in the west, but so do the stars. On a dark night, far from city lights, you can see a few thousand stars in the sky. The ancients organized what they saw by naming stars and groups of stars. Some of those names survive today. All around the world, ancient culture celebrated heroes, gods, and mythical beasts by naming groups of stars, constellations. You should not be surprised that the star patterns do not look like the creatures they represent any more than Columbus, Ohio, looks like Christopher Columbus. The constellations simply celebrate the most important mythical figures in each culture. The constellation named by Western cultures originated in Mesopotamia over 5,000 years ago. With other constellations added by Babylonian, Egyptian, and Greek astronomers during the classical age. Of these ancient constellations, 48 are still used today. To the ancients, a constellation was a loose grouping of stars. Many of the faintest stars were not included in any constellation, and the stars of the southern sky, not visible to the ancient astronomers of northern latitudes, were not grouped into constellations. Constellation boundaries, when they were defined at all, were only approximate, as you may see on the upper figure A. So, a star like Alpherat could be thought of as part of Pegasus or part of Andromeda. To correct these gaps and ambiguities, astronomers have added 40 modern constellations, and in 1928, the International Astronomical Union established 88 official constellations with clearly defined boundaries, as you may see as example on a bottom picture. Consequently, a constellation now represents not a group of stars, but an area of the sky, and any star within the region belongs to one and only one constellation. Alpherat belongs to Andromeda. In addition to the 88 official constellations, the sky contains a number of less formally defined groupings called asterisms. The Big Dipper, for example, is a well-known asterism that is a part of the constellation Ursa Major or Great Bear. Another asterism is the Great Square of Pegasus, as you may see on the bottom figure, which includes 3 stars from Pegasus plus Alpherat from Andromeda. The star chart at the end of these our classes uh, in and will introduce you to the brighter constellation and asteroid. Also, constellation and asteroids refer to stars grouped together in the sky. It is important to remember that most are made up of stars that are not physically associated with one another. Some stars may be many times farther away than others and moving through space, even in different directions. The only thing they have in common is that they lie in approximately the same direction from Earth, as you may see from this slide. In addition to naming groups of stars, ancient astronomers gave individual names to the brightest stars. Modern astronomers still use many of those names. The constellation names come from Greek, translated into Latin, the language of science from the fall of Rome to the 19th century. But most star names come from ancient Arabic through much older by the passing century. The name of Betelgeuse, the bright red star in Orion, for example, comes from the Arabic yard al-Jazwa, meaning shoulder of Jazwa, Orion. Names such as Sirius, the scorched ones, and Aldebaran, the follower of the Pleiades, are beautiful additions to the mythology of the sky. Naming individual stars is not very helpful because you can see thousands of them. How many names could you remember? A more useful way to identify stars is to assign Greek letters to the bright stars in a constellation in approximate order of brightness. Thus, the brightest star is usually designated alpha, the second brightest beta, and so on. Often the name of the Greek letter is spelled out and is alpha, but sometimes the actual Greek letter is. For many constellations, the letter follows the order of brightness, but some constellations, by tradition, mistake, or the personal preferences of early chart makers, are exceptions. To identify a star, its Greek letter designation, you give the Greek letter followed by the possessive or genitive form of the constellation name. For example, the brightest star in the constellation Canis Major is Alpha Canis Majoris, which can also be written Alpha Canis Majoris. This both identifies the star and the constellation and gives a clue to the relative brightness of the sky. Stars. Astronomers measure the brightness of stars using the magnitude scale, a system that first appeared in the writing and the ancient astronomer Claudius Ptolemy about 840. The system probably originated earlier than Ptolemy, and most astronomers attribute it to the Greek astronomer Hipparchus about 190 BC. Hipparchus completed the first known star catalog, and he may have used the magnitude system in that catalog. Almost 300 years later, Ptolemy used the magnitude system in his own catalog, and successive generations of astronomers have continued to use the system. The ancient astronomers divided the stars into 6 classes. The brightest were called first magnitude stars, and those that were fainter, second magnitude. The scale continued downward to 6 magnitude stars, the faintest visible to the human eye. And thus, the larger the magnitude number, the fainter the star. And this makes sense if you think of the bright stars as first-class stars, and the faintest stars visible as 6th-class stars. Modern astronomers can measure the brightness of stars to high precision, so they have made adjustments to their ancient scale of magnitude. Instead of saying that the star known by the charming name Chor Theta Leonis is third magnitude, they can say its magnitude is 3.34. Accurate measurements show that some stars are brightest than magnitude 1. For example, favorite star Vega Alpha Lyrae is so bright that its magnitude 0.04 is almost 0. If you are so bright, the magnitude scale must extend into negative numbers. Look on this left side. On this scale, our favorite star, Sirius, the brightest stars, look at this, the brightest stars in the sky has a magnitude minus 1.47. Modern astronomers have had to extend the faint end of the magnitude scale as well. The faintest stars you can see with your unaided eyes are about 6 magnitude. But if you use a telescope, you will see stars much fainter. Astronomers must use magnitude numbers larger than 6 to describe these faint stars. These numbers are known as apparent visual magnitude M sub V, and they describe how the stars look to human eyes observing from Earth. Also, some stars emit large amount of infrared or ultraviolet light. Human eyes can see it, and it is not included in the apparent visual magnitude. The script V stands for visual and reminds you that you are including only light you can see. Apparent visual magnitude also does not take into account the distance to the star. Very distant stars looked fainter, and nearby stars looked brighter. Apparent visual magnitude ignores the effect of distance and tells you only how bright the stars looks as seen from Earth. Your interpretation of brightness is quite subjective, depending on both the philosophy of human eyes and the psychology of perception. To be accurate, you should refer the flux, a measure of the light energy from a star that hits 1 square meter in 1 second. Such measurements precisely define the intensity of starlight and the simple relationship concepts apparent visual magnitude and intensity. In this way, modern astronomers can measure the brightness of stars to high precision while still making comparison to observation of apparent visual magnitude that go back to the time of Hipparchus. Next astronomy lecture will be the sky and its motion. I hope you enjoyed this lecture, and I'm looking forward to see you next time. Okay, bye.